This is 5.3, graphing quadratic inequalities. So very much like graphing linear inequalities, depending on the inequality symbol, in this case where y is greater than or equal to x squared plus x minus 12, the solution area is shaded because all the solutions for this particular quadratic inequality are above the line. In this quadratic inequality, y is less than or equal to, you'll notice that the area is shaded below the line because all the solutions are below this parabola. Okay. In both cases, you'll notice that the line is drawn with a solid line because it's less than or equal to or greater than or equal to. So very similar to the linear inequality parts. And just like with the linear inequalities, this is the same sort of idea where we are now replacing the equality symbols with the inequality symbols. Let's get my pen going here. So we can have y is greater than ax squared plus bx plus c, or y is greater than or equal to x squared plus bx plus c. And you guessed it, on the other end, y is less than x squared plus bx plus c. Y is less than or equal to ax squared plus bx plus c. Notice that a, b, c are constants and a cannot equal 0, because if a equaled 0, then it would turn it into a linear inequality. Okay, so how do you graph it? Notice it says not, it doesn't say using technology, it just says graph this. Okay, so we take a look at this, look at the values of the p and the q, and we can see the vertex is going to be at 0, -4. Okay, so that gives us one point where we can graph. The other part I think I want to graph is we want to take a look at the x-intercepts. So we'll just set the y equal to 0 and solve for x. So we'll add 4 to both sides. Divide by 3. And then take the square root. So remember that square root can be positive or negative. And if we were to translate to an actual number, that would come to be about plus or minus 1.2. Okay, so once we have those pieces in place, we have a vertex, and then we also have two x-intercepts. That makes it very easy to sketch. So we'll label this my x, label this the y. Here we have the vertex at 0, -4. And just to make it more visible, I'm going to put a red dot where the vertex is. And then I'll put in a couple of marks for x-intercepts. 1.2 is about there, 1.2 is about there. Alright, now we take a look at the inequality symbol. It's less than, so I know that my line has to be a dotted line. Okay. A dotted line through the vertex and the two x-intercepts. Put arrows at the end of the functions. And because it's less than, I'm going to shade below the function. There it is. Okay. Go to page 161 and try to check on your own. Okay. Next up, we're going to take a look at graphing this using technology. Well, this is really quite simple. I think what I want to do, first of all, is change this inequality symbol to greater than. First of all, okay, so we'll take this out here, and we'll make this greater than. All you're going to really need to do is go to your calculator and enter the quadratic inequality. Remember this from the linear inequalities. If you wanted to shade above, you just hit this symbol pointing up. So what I'll do is I'll press y equals. Clear the old equation out. Well, actually, this is 1.5 x squared plus 2.8x 2.8 also notice over here I've got a greater than symbol, which is what we want. And maybe zoom 6. Most of these are kind of standardish parabolas. Gets us inside the window. There it is. So all I'm going to do is, once I finish that, take this and sketch it out like so. So that's pretty simple. I want you to try the check graphing this linear inequality. And again, as always, if you're having trouble with these checks, the full solutions are in your work text. Okay, last word problems. So the word problems has kind of a formula to it. There's kind of step by step. So if you follow the steps, it really helps you. Two numbers are related in this way. So you've got two numbers. So let's call the first number x. Break it down. And the second number equals y. The sum of 2 and 3 times the square of one number is greater than or equal to 5 minus twice the other number. Okay, so think about it. The sum of 2 and 3 times the square of one number, 2 plus 3 times the square of one number is greater than or equal to 5 minus twice the other number. 5 minus twice the other number. Okay, so let's bring the 2y over here. Solve for y in this case. We'll subtract 3x squared. We'll subtract 2 from both sides, so it gives us plus 3. And then we'll just divide everything by 2. So y is going to be greater than or equal to, let's put this to a decimal, 1.5, sorry, negative 1.5x squared plus 1.5. Okay, so we do the same thing now. Graph an inequality that represents this relationship. So we've got to figure out what the equation is first. Here, the vertex, if we look at our p and our q value, vertex is going to be at 0 and 1.5. And let's find out where the x-intercepts are by setting y equal to 0. Subtract 1.5 from both sides. Divide both sides by negative 1.5. And take the square root of both sides. So it's plus or minus 1. Okay, so my vertex is at 0, 1.5. That's going to be right here. And my two x-intercepts are at 1. I take a look at the inequality symbol, greater than or equal to, so this is going to be a solid line. Because it's greater than or equal to, we're going to shoot above it. And for part B, it says use the graph to list a pair of integers for the two numbers. So these are all these possibilities. Anything that's up in the shaded area here would work. So B, we could do something like, what would work? 2, 2, negative 2, negative 2, 4. All you have to do is pick it out of there. Okay. Try the example on page